Hello and welcome to my final end of quarter video for scaffolded exercises. So to start, it is hard to understand how different pieces of code in a program work together, especially when some functionality is invisible. So for example, this GIF on the right, let's take a predictive search page where results update as users enter their search query. There may be multiple components all working together with only a few of them directly yielding a visual update. So for example, there's an event listener attached to the search bar that is activated on key up or whenever a site visitor presses a key. There may be a callback function associated with this event listener that hits a search API endpoint, and then there may be a results parser that removes any irrelevant or inappropriate search contents. And finally, there might be a function that replaces the current content on the page with new content in the appropriate part of the DOM to reflect the completed search. So, intermediate web developers may struggle to understand how the query is passed into the program and propagated to all these different code components that are responsible for loading and re-rendering the search results page. However, this series of transformations is critical to understanding data-rich professional interactive web pages. But again, it's also very difficult to understand from looking at a page just by itself or even looking at its source code on Chrome Developer Tools or something like that. Site source code is messy and it's complex, and visuals often hide the important and visible steps in the program. So, what do intermediate developers need that they don't already have to understand these particularly challenging web concepts? So, our core finding is that we need to create process management scaffolds based on a learner's visual intuition to help the learner understand how data is created, used, and modified to create professional web pages. So this quarter, we honed in on this language to describe the value of SE, of scaffolded exercises, and completed the implementation of source code breakdown into process managed exercises to support this core finding. I have an entire video and code documentation explaining how the system actually runs and creates those exercises. So for this video, I'm going to focus on higher level takeaways from the quarter. And you can see the system demo in the scaffolded exercises playlist on the Delta Lab YouTube. So scaffolded exercises creates process management scaffolds by identifying the most recently executed JavaScript that modified the DOM and creating a series of exercises in reverse order of execution of the code that created the visual updates. So it links information to visual intuition by surfacing the invisible program data related to the DOM modifying code. And we'll see an example of this in the next slide. So hopefully it'll make it clear what I mean. These affordances help developers understand which code components interact with which program data or DOM elements and understand how individual and combined code components create complex functionality through the use and modification of program data. So here is an example of an exercise where the code shown in the pop-up box right here is the code that most recently modified the DOM. And you can see how a learner could use their visual intuition to understand how the values of the position variable affect the location of the map div. This is not usually an easy observation to make in something like, for example, Chrome Developer Tools, if you're just looking at the site source code, where all of this information is spread across multiple separate panes. And in CDT, for example, you have to pause program execution via breakpoint setting in order to see program data information, which does not help build a connection between visual intuition and how the code that creates those visual updates works, because you're actually pausing the visual updates instead of helping them. So here you can see, okay, I see position here, I see position here, and I see the same values here. So what does that mean? How can I connect the fact that I have this variable, which equals this item? And then as you're moving the screen around, you can see these values updating. And that can give you a really good sense of how the underlying code is actually influencing the DOM. So there were two main system efforts that were needed to be able to create the kind of exercises that I just showed you. Last quarter, I focused on implementing the variable value tracking. So that's that position variable that you see, and you can see it live updating. And you can see more information on how it works in my previous end of quarter video or in this quarter's system demo. The second system effort is the code breakdown and exercise ordering, and that's what I would focus on this quarter. I described the logic for how to break down code based on code properties in another video in the Scaffolded Exercises YouTube playlist, and I show what that looks like in the system demo from this quarter, but this is what I focus on. So I'm going to talk a little bit about high level things that were added in order to implement this and what the outcome looks like. So in order to create the data necessary to break down the source code into the order exercises, we had to increase the instrumentation that we had already had in place that we were using to create the state manager. Um, what we ended up doing was including library methods and methods that were assigning other variables, or what I'm here calling right-hand side methods. So those are things where it's say maybe like variable x equals, and then there's some sort of method on the right side. We're now tracking over all of that, as well as library methods. So things like map.css. Map.css is actually a jQuery library method, but we're able to instrument over that. So you don't have to instrument over all library source code, but you do instrument over the library code that's included in the programmer written code, or that the programmer writes on top of. So we also, beyond the increased instrumentation, had to figure out a way to download data from when the code was running so that we could analyze that data to figure out what the right pieces of information to surface to the learner was. Finally, we had to figure out how to classify each code component that interacts with the DOM as either initializer code, so code that sets up the web page, user code, so that's code that uses the DOM object but doesn't change it, or modifier code, which is code that uses the DOM object and changes it. And this classification was important for for exercise ordering purposes. And it required an extra instrumentation and running step, which is now looking really similar to how Isopleth runs once and then must be reloaded and run again before it can generate a call graph. So to the right, you see an example of what the first exercise returned from the exercise breakdown algorithm. And that is actually the exact first exercise that I was hoping would be returned in an ideal world. So that's exciting. Um, so our next step, so now that we have both components of the backend system completed, the next step is to link the interface, so that exercise that I showed you a few slides ago, to the backend system. So that's being auto-populated. In a perfect world, there'd be some, code linting and code cleaning stuff that was also automated, but overall that system is complete. The next thing would be to design and run a user study with this updated automated system and run it on more than one site, the next KCD. I have the variable value tracking working on another site, Maps TD, and also started to run. I'm going to test to run the exercise breakdown on it and see what turns up. And then possibly, depending on how the progress of all of this goes, a next step could be to finalize the paper draft that I started writing this quarter. So that is the status of scaffolded exercises as of spring 2020. Thanks.